Assalamualaikum. So I'm going to talk about chapter 2. We are going to start with chapter 2 today. The title for chapter 2 is Corrosion Science. At the end of this topic, you should be able to describe the corrosion of metal when exposed to the environment. Okay, the rest will be covered tomorrow or next week. So corrosion of metals. So this is the definition of corrosion of metal. Corrosion is the result of interaction between a metal and the environment, which result in its gradual destruction. Okay, when metal exposed to the environment, so it will slowly or gradually will corrode. Okay, then it will start to destruct. So these are the list of typical corrosive environment can affect these metals or alloy. So one is the air, oxygen, and humidity, the water. Okay, the presence of water and oxygen will make the metal corrode. Besides that, fresh distilled salt and marine water will further accelerate the corrosion of metals. Okay, the presence of salt, for example, in seawater, it will make the metal corrode faster. Then natural, urban, marine, industrial atmosphere, okay, the steam gases like chlorine, ammonia, hydrogen sulfide, sulfur dioxide, oxide of nitrogen, all this present in the atmosphere, okay, SO2 and O2, okay, will tend to form sulfuric acid and nitric acid. Okay, so all this as well as fuel gas contain CO2, it will tend to react with the environment, water, to form carbonic acid. All these acidic solution, they will affect the metal and alloys. Okay, so acid, alkalis, and soil also can corrode the metals. Okay, so look at this, the diagram, corrosion cycle. So this is a cycle of corrosion of metals. Okay, let's say it start with the most stable, thermodynamically stable, the ore. The ore present in the earth crust. Okay, so in the form of oxide. For example, iron ore in the form of ferric oxide. If aluminium oxide, okay, present in the earth crust. So then the miner will get it from the crust. They take the ores from the crust, and then they start do the process of extraction, okay, to refine the ores to make it metal, pure metal. Okay, for example, iron oxide or ferric oxide will be extracted, and then we'll do the extraction process, and will become pure metal, pure iron. Okay, so it probably will mix with carbon to increase the mechanical strength of that metal. So this we can call it mild steel or steel. Okay, but this metal is thermodynamically unstable. Okay, it will easily react with the environment because through this process. Okay, iron, ferrum will react with the environment, will undergo the corrosion process because it tends to be stable back to its origin. Okay, from this unstable to become stable oxide, the oxide compound of that metals. This is the cycle, we call it corrosion cycle, from unstable to be stable product, okay, through the corrosion process. So the corrosion process is the reaction of metals and the environment, okay. In the presence of water and oxygen, they will form oxide of the metal. So what are the consequences of corrosion? So there are many consequences can happen due to corrosion. One is the shutdown of plants. Okay, so for example, the process plant, nuclear plant will be shut down, okay, due to corrosion of the plants. Okay, normally metals are used to construct the plants. So the cheap metal is normally they will use steel. Okay, so when steel will corrode with time, so it will make the plant to be shut down. Okay, and another consequence is the loss of products such as leaking. Okay, like petrol station, it contains storage tank underneath or underground, so it will react with the environment. If it is not protected, if the tank is not protected, so it will slowly or gradually it will leak the products. For example, petroleum, okay, scap in that tank will be released to the atmosphere. So the petrol station will lose the products. Okay, next, loss of efficiency. Okay, so for example, in heat exchanger tubing pipelines, okay, the corrosion product will reduce the heat transfer in piping capacity, so the loss of efficiency. Then contamination, so you can relate with the loss, the leaking into to this contamination. Okay, if you keep waste, chemical waste in a container, the container made of steel, so it will corrode, then it will leaking problem will make the contamination of the surrounding of the atmosphere, so it will affect the ecosystem, aquatic system. Okay, there is contamination. And also the explosion, okay, the nuclear hazard such as Chernobyl disaster in Russia. Okay, so all this due to corrosion. So corrosion also give the economic impact. So the cost of corrosion can come in two ways. One is direct cost, another one is indirect cost. Okay, direct costs such as replacement of corroded components. If you want to replace the corroded component such as bridges, okay, the metal bridges, okay, and the plants, it will cost, you have to spend money to replace the corroded component to a new object or new bridge, something like that. Okay, then the use of corrosion resistant, or you can also change the, for example, steel to stainless steel. But stainless steel, the alloy, stainless steel is alloy, is more expensive than steel. The use of coating, this one of the techniques or inhibitors can be used to stop or to inhibit the process of corrosion. But still, it will get, you must have money to be dumped into this protection method. So this is all under direct costs. So this electrochemical protection measures also method will be discussed later in the second part of this chapter 2. Okay, for indirect costs, the loss of product due to leakage, okay, loss of efficiency, contamination, loss of human life due to explosion, all these considered as indirect costs. Okay, it can be related to the corrosion. Okay, but that is under indirect costs. Okay, the corrosion can be controlled. Okay, there are several methods can be used to control the corrosion. One is through material selection. Second is through proper design. Third is alteration of the environment, okay, from corrosive to less corrosive. Then electrochemical protection. That is by using inhibitors. Last one is using paint or through coating. Okay, all these 6 will be discussed in the second part of this chapter 2. So the significance of corrosion control in economic, safety, and environmental concerns. Okay, so that's why we must control the corrosion of item or object in order, in terms of safety, in terms of economic, and as well as environmental concern. Okay, next we look at this corrosion. Actually, is a galvanic process. So this is the adverse effect of corrosion of galvanic. Okay, corrosion is a galvanic process. So you have learned, I have discussed about galvanic system cell. It must contain this. Okay, one is anode, then cathode, and also a solution must be present, and also the electron pathway. Okay, this is the electron will flow through the external circuit. Okay, so this is from the chemical energy will generate or produce voltage. This is electrical energy. It's a spontaneous reaction. Galvanic is a spontaneous reaction. So similar to corrosion. Corrosion also is a spontaneous reaction. Okay, so look at this. Corrosion is a galvanic process by which metal deteriorate through oxidation, usually, but not always to their oxide. Okay, so it means that the metal M, for example, will oxidize to its cation and release electron. Okay, some metals will oxidize to form its oxide. Okay, oxide. For example, N. Okay, so for example, iron is Fe will rust. Okay, if iron, the terminology for the corroding of iron is iron will rust to form rusty product. For example, ferric oxide. Next, silver. Now the metal also can oxidize, but it's quite stable. Silver can tarnish. It will form products, silver oxide. Next, copper. Okay, or brass. Brass is the alloy for copper. The combination, the addition of zinc in copper plus zinc, we call it brass. If bronze is copper plus titanium. All right, so for brass, it will they will acquire a bluish green surface. Okay, when it turns, originally it's in dark color, dark brown, it will turn to bluish green surface. That product we call it copper patina. Okay, so under ambient, we look all these example later. Okay, so under ambient condition, the oxidation of most metals is thermodynamically spontaneous. Okay, except gold. Gold is Au and platinum, Pt. These two metals are inert and very stable. It won't oxidize to their ions, for example, Au to Au plus or Pt to Pt3 plus. Okay, they can oxidize if only a strong oxidizing agent present when you expose these metals to strong oxidizing agent, such as permanganate, okay, hydrogen peroxide. Okay, if in normal environment, for example, the presence of O2 plus water, so gold will not oxidize to its ion, will not, as well as platinum. They are very inert, okay, very stable. So some metals, however, are resistant to corrosion for kinetic reasons, such as aluminium. Okay, so certain metals, for example, aluminium, in normal or neutral environment, it can form oxide product. Okay, this is alumina, which is also very high corrosion resistant. Okay, as well as titanium will form titania. Okay, the formation of oxide layer or oxide product of these two metals. They are reactive. Both are reactive metal if exposed to very strong acidic or strong alkaline solution, very corrosive solution. But in normal environment, pH 4 to 9, they will produce oxide layer on their surface, okay, which are high corrosion resistant properties. The properties of that oxide is high corrosion resistant. It's difficult to corrode. Okay, so normally aluminum is used in soft drink cans, in airplanes. Okay, because the presence of oxide layer, thin film of oxide layer, will protect the corrosion of that material. So look at this diagram, the corrosion susceptibility of metals. Okay, going upwards, these all are reactive metals and alloys. Okay, and moving downward is all very good metals. They are noble metals. Okay, it's difficult to corrode. Okay, but going upward, it easily corrode to form ions. Okay, this is the photos, the image of platinum bar. Okay, it's very expensive. Okay, as well as this gold, because they are very stable, they are inert. That's why they are very valuable, priceless. So this is ferrum, also known as steel. Okay, so it will produce rust. Okay, because ferrum is reactive. For example, mine steel, okay, steel. So it's located in high position, okay, it's easily corrode to form rust. So this is rust, dark brown color, okay, reddish brown. So next metal is silver. Okay, silver also, when exposed to oxidizing condition, it will form oxide or sulfide. This compound, we call it tarnish. Okay, look at this spoon. Okay, originally it's shiny, like this coin, shiny. Okay, it will turn to tarnish. This becomes a gloomy appearance, so this we call it tarnish. Okay, so silver is the very conductive metal. Okay, it's the highest conducting material, silver. Okay, in terms of conductivity, silver is the highest metal as the conductivity. Next material is copper. Okay, when it oxidizes, it tends to form patina. So this is original color appearance of copper, but slowly with time, over time, it will change to very dark brown color, black color, and after 4 to 30 years, slowly turn to green color. Okay, this we call it copper patina. Okay, a lot of sculptures or object in Europe or in US state, for example, this is a very popular landmark. Okay, Statue of Liberty. Okay, located in New York. Okay, in 1895-96. Okay, it looked like this. Brown is copper color appearance, and then slowly it changed to green color. This is copper patina. Okay, when the metal copper reacts with the environment, okay, then oxide and sulfur, okay, so it will change to copper sulfate. It's copper patina. So this is metals have many application because they have this protective oxide layer. So for aluminium will react with environment in very in neutral waters or neutral environment, ambient temperature environment, will tend to form aluminum oxide. So it can be used to produce this aluminum can, okay, the sliding doors, window panels, cars body, okay, but we mix with other metals. Okay, the good about aluminium is light, very light. Okay, the density of aluminium is 2.7. It's the lightest among the lightest. The lightest is magnesium. Okay, so but it's very reactive. But aluminium is good. Okay, light metal, and also very strong, durable, and it can be used to produce aeroplane, the body of aeroplane, because due to this lightweight property. Okay, next metal which has application is titanium. Okay, will react with environment, it will form titanium dioxide. Okay, so it's very strong, and it can be used in dental, to be used in dental implant, in medical. Okay, this is skull reconstruction, the artificial skull. Okay, and this is for spinal correction, spinal backbone in scoliosis patient. Okay, this is also can be used to make golf sticks. Okay, very strong, very hard, and very high corrosion resistant titanium. Okay, so next, this statement: chromium, magnesium, nickel, okay, also can form protective oxide film. Okay, so stainless steel contain all these elements: chromium, magnesium, nickel. Okay, so normally it contains chromium and nickel because steel is consists of ferrum and carbon, but its corrosion resistance of steel is low. In order to improve its corrosion resistance, steel is modified and it add chromium beside ferrum and carbon. Chromium, nickel, and manganese are added into the composition to produce. This is called stainless steel, which is high corrosion resistant. Metal or alloy. This is alloy. Okay, alloy, when we mix in that material has more than 2 metals, we call it alloy. If one metal, we call it pure metal. In contrast to these metals, when iron corrode, it forms a red-brown hydrated metal oxide. This is the chemical formula for rust. Okay, the problem with steel, even though it has oxide, the formation of oxide for ferrum, but the oxide film is easily flake off or peel off from the surface, from the substrate. Okay, ferrum also can produce oxide. Okay, but for ferrum, okay, this is, we call this rust. Okay, the problem with rust iron, you look at this photo. Okay, the oxide layer is not intact. Okay, not adhere very strong to the iron surface, not like ferrum, aluminium or titanium. Both the formation of oxide is very intact. Intact means that it strongly adhered to the substrate, the formation of oxide. Okay, so when the formation of alloy for steel, this is stainless steel with the addition of chromium, nickel, manganese, all these can form oxide, but intact oxide layer. Okay, intact. So when the formation of intact oxide layer on the surface of ferrum, it will improve the corrosion resistant property of steel. So this is the example, the application of stainless steel. Okay, next, there are 4 essential components of a corrosion cell. It is similar to galvanic cell. Galvanic cell. So it's a galvanic cell or corrosion cell must have 4 essential components. One is anode. Next is cathode, electrolyte, and also the electron pathway or electrical connection. Okay, so we will call back to this galvanic cell. Okay, all the 4 components must be present. One is anode. This is anode. This is cathode. Next, electrolyte, and also the electron pathway. Anode, cathode, electrolyte, the solution, and also the metallic pathway. If any one of the 4 elements, if one is missing, for example, there is no cathode or electrolyte, so the corrosion will not occur. Okay, in corrosion cell, so electron will flow from anode. This is anode. The electron will flow from anode to cathode. Okay. Current is the positive charge will flow the opposite direction from cathode to anode. Okay, then current in the solution, okay, will flow from anode. This is current, will flow from anode to cathode in the electrolyte solution. Okay, now we come to the theory of rusting. Okay, so corrosion of iron under a drop of water. So you can imagine this is a drop of water, the blue color. Okay, next, the presence of oxygen in the atmosphere surrounding the droplet, water droplet. So this water droplet falls on a metal surface. Okay, so you imagine water droplets, so will fall on one strip of, for example, ferrum, will go down, so it will form a semicircle. Okay, so this is the metal, so this is water. Okay, surrounding the water droplets already attached or absorbed on the surface, there are oxygen present. So this oxygen will diffuse into the water. Okay, so the oxygen is already in the water, so it will create a different in concentration of dissolved oxygen. Okay, so at the middle, the O2 present is less than at the edges. Oxygen at the edges is higher than at the middle. So this is ferrum. Okay, so the middle will be anode. This will be anode. And the edge will be cathode. Either this side or this side, cathode. More oxygen, cathode. Less dilute is anode. Okay. So Okay, we erase this. Okay, the difference in dissolved oxygen, so will form a corrosion cell. Okay, so this is ferrum. So at the middle will be anode, so it will start to oxidize. This is water. Okay, so for corrosion of iron at anode, ferrum, the metal, will oxidize to ferrum 2 plus and release 2 electrons. Cathode, this is anode, this is cathode. So is alkaline, so water, in water with the presence of oxygen, okay, will accept 4 electron, will produce hydroxide ion. Okay, so for overall reaction of this rusting process, okay, this, the top one, the anodic process, must be multiplied with 2. Next, you will get 2 plus O2. You cancel the number of electrons, plus 2 ferrum will produce 2 ferrum 2 plus and 4 hydroxide. Okay, so you will simplify it. Okay, this is the reaction, and this will further oxidize. It will form hydroxide. This is ferro hydroxide, and will react with oxygen, further oxidize to form before that, the formation of ferric hydroxide, and finally it will form rust. Okay, this is rusting process. Okay, so ferrum will react with water. Ferrum will react with water, and the water contain dissolved oxygen, and it will oxidize to iron 2 or ferrum 2 and also hydroxide. So these two will react to form lower oxidation compound of ferrum, which is ferro hydroxide. It's not very stable. It will further oxidize to ferric hydroxide, and then it will form the more stable compound, which is rust, ferric oxide. Okay, you can read through this notes. Okay, all this refer to the same explanation for this reaction, the formation of rust when ferrum or iron react with this environment. Okay, last slide is the electrochemical reaction. Okay, when metals, this is metals, so the anodic reaction, electrochemical reaction is the redox process. Okay, so this is anodic and also cathodic reaction. So in the corrosion of metals, so the anodic reaction is the process of oxidation of metal. Metal M will oxidize to higher oxidation state. This is solid 0, will become ion and release electron. Okay, for example, metal ferrum will oxidize to ion, ferrum 2, and release 2 electron. For aluminium, metal aluminium will oxidize to aluminium 3 and release 3 electron. So, if there is anodic reaction, the cathode also must be present to complete to form electrochemical reaction. So the possible cathodic reaction, for example, if the metal is exposed in acidic solution, which is pH less than 7, okay, so this either in the presence of water, the presence of oxygen, okay, the presence of oxygen, okay, without the presence of oxygen, okay. With the presence of oxygen, another term is aerated, or also known as oxygenated. So this H plus in the reaction, this represent acidic. So in this acid solution, oxygen is present. So you must use this voltage. You can get it from standard electropotential series. So this is the reduction of oxygen to form water. So pH less than 7 because acidic solution, H plus. So in this acid, oxygen is present. So you must use this half cell reaction at 1.23 volt. If the condition is without oxygen, not water here, oxygen, or also known as the absence of oxygen, okay, also a term also used is deaerated or deoxygenated. It means there is no oxygen. So, and acidic, the solution is acidic. You must use this half cell reaction at 0 volt. If the solution, you expose the metal to this solution, neutral, pH 7 or more, and alkaline, so in the presence of not water, oxygen, okay, so or also known as aerated, you must use half cell at 0.40. This is alkaline or neutral, and in this solution contain oxygen, so it will oxidize to form hydroxide. If without dissolved oxygen but alkaline or neutral, pH more than 7 or equal to 7, so you must use this half cell reaction without oxygen. There is no oxygen present, or also known as deoxygenated. There is no oxygen, so you must use this negative 0.83 volt. Okay, so you can see this. There are 4 half cell reaction represent water reduction. H2O so can be present as H plus OH, or also as molecule of water. Okay, so one is without, one is without, one is with oxygen, one is without oxygen. Okay, so if pH less than 7, these two, one is with oxygen and the one is without oxygen. If the solution is 7 or more than 7, you must use this half cell with oxygen, or this without oxygen. Thank you.